So now we'll move on, taking a look at question 3. Question 3 is one of those standard ones that you can use for the Pythagorean theorem. I don't know of how many people actually would do this type of work. I mean, usually just grab a ladder, put it against the wall, and hopefully it's at a good angle to get up to where you want to get to. But in math, we always play around with the ideas of, as much as we can, we try to make it as real to life. So with the information we have. So you've got a 12-meter ladder, okay? And what we've got here is, so you can say, fine, here's the wall. Your 12-meter ladder is leaning up against the wall. The ground is always at 90 degrees to the wall of any building. That's what it's assumed to be. So we know that this is 12 meters there. The top of the ladder reaches a window that is 12 or 10.5 meters above the ground. So you know that this is 10.5 because the window is basically right there at the top. Calculate the distance from the base of the ladder to the wall. So again, you're calculating that one there. And what I'd like you to do is maybe you can work on that one on your own to try to set it up correctly. Okay. We'll take a look at doing the ratios. We are going to be dealing with ratios quite a bit, and the ratios themselves are going to start off by looking like fractions themselves. So if we were to change the fractions or change the ratios to fractions, 4 to 8 could be written like 4 over 8. And so what we're going to do is we're going to reduce this. We can see that the 4 goes into itself once and into 8 two times. So the fraction could be 1 over 2. The ratio, if we need, is 1 to 2. Okay, the same way. If you're looking at 15 to 35, what is the common factor? What is the common number that can divide evenly into 15 and 35? And you should be able to say, oh, it's 5. So what we do is to get from one ratio to the next, okay, if you want to keep with the ratios, we can divide the 15 by 5 and get 3, divide the 35 by 5 and get 7. And you can see that that is itself, a reduced ratio. Okay. C should be an easy one there to see that, yes, in fact, you're just dividing by 10 in each case, so you're going to end up with 2 to 5. All right. Where we use this is basically more so with the question number 5. Question 5 itself has the ratio between the selling price and the purchase price of a computer chip is 18 to 7. If a computer chip sells for $27, determine the purchase price of the chip. So you're dealing with the ratio, and it's how it is written in the question itself. You can see that in this one it says the ratio is the selling price, okay, and the purchase price. So it's selling price to purchase price, all right? And it's 18 to 7. So it's 18 selling to 7 purchase, okay? If the computer chip sells for $27, it sells for $27. Okay, determine the purchase price of the chip. So what you have here, what you say is you write the equivalent ratio. In this case, it's 18 to 7. The ratio between selling price and purchase price is equal to, now the computer chip sells, so selling was first, so we write the 27 first. Okay, and then we have whatever the purchase price is. We don't know. We normally call it X. So what I like to do is what I did in the last question is I like to convert these into fractions. So 8 to 7 or 18 to 7 would be 18 over 7. And then you have the 27 over X. And you can solve for it and see, well, what do I do? How do I solve for X? So again, we're using that idea of isolating for the variable. Okay, I'm going to tell you on this one here, when you only have one fraction on one side and one fraction on the other side, you can quickly invert the fractions, flip the fractions. We're going to use this a few times this year as well. That gives you the X on top, and so all we have to do is get rid of that divide by 27. So to get rid of a divide by 27, you multiply by 27. All right, so you can see the 27 is reduced to 1. We're left with x on the right, which is what we want. And now we can just multiply the 27 into the 7 over 18. What I like to do on that one is I say, well, the 18 can be divided by 9 twice. The 27 can be divided by by 9 rather 3 times. And so now I'm just left with 3 times 7 is 21 over the 2. So basically the x is 10.5 if you wanted to go with a fraction. So 10.5 there. All right. So again, there's a bunch to do. We're dealing with these ratios. Okay. And we've got to know how to deal with ratios and how to calculate certain things here and there. All right. For example, okay, the more that we get familiar with these, the easier some of our questions in the trig are going to be, because all we're going to be doing is, manipulating questions very similar to A here. Some of them are going to be a little tricky, like B, because it'll have the variable in the denominator, but we just have to get used to what we're doing and how to do it. Okay, so refresh your memory on these things there. All right. What I want to do is get into basically, I'll talk about the angle sum, but first make sure that you know how to calculate these. You're going to be dealing with that in your calculator. Each calculator is a little bit unique, so make sure you're all getting the same answers. Okay, in the back of the book will have these answers with them as well. Okay. One of the ideas that we're going to use all the time is basically the angle sum of a triangle, or the sum of the angles of a triangle theory, which we talked way back in grade 9 about. And you know that all the angles inside of a triangle add to 180 degrees. So if you wanted to determine the angle sum, or an angle in, let's say, A here, we want angle B, well, we know that it has to be 180 degrees minus the other two angles, because they have to add up to 180 degrees. Okay, so that's what angle B is going to look like. So again, how do we do it? Just put it in your calculator. 180 degrees minus 82 minus 74 gives us 24. So we have 24 degrees for angle B. Okay. Question B. Now it's a little different. You may not be able to see it on the screen here, but there's actually a tick mark between AB here and a tick mark between AC here, which means that this is an isosceles triangle. Since we know that is true, that angle B is the same size as angle C. So how do you find what each individual angle is? Well, again, you know that angle A is 42. So we know that 2x's is going to be 180 degrees in total minus the 42 degrees. Okay, so the 2x's is 180 minus the 42, and we've got 138 degrees there. And so we divide both sides by 2 to get our final answer for each individual one, and that's 69 degrees. Okay, one thing to take note of, we're going to use this quite a bit. That symbol there means 90 degrees. Okay, we know that. We've used it for many, many years, so you can come up with figuring out the angle of A on that side. All right? Okay, in the next video, we're going to take a look specifically more about trig ratios. Okay, and we'll leave this as it is right now.